Thank you for choosing American Pest CEUs.
Hello, everyone. I'm Sean Reeves. I'm an associate certified entomologist with American Pest CEUs, and I've been in the pest management industry since 1999. I'll be your instructor for today's course.
Today's course is titled Weeds of Lawns and Gardens, Part 1, and was prepared by Jack Launius. Weeds are unwanted plants that compete with the desired plants for resources such as water, nutrients, and sunlight. They can be a major problem for lawns and gardens as they can reduce the overall health and appearance of the landscape. It is important to understand the types of weeds that are common in your area, as well as their growth habits and life cycles. This knowledge can help you develop an effective weed control strategy that is both safe and environmentally friendly. Prevention is the best approach to weed control. This can include practices such as proper watering and fertilization, regular mowing, and the use of mulch to prevent weed seeds from germinating. When weeds do appear, it is important to take action quickly to prevent them from spreading and becoming a larger problem. There are several methods of weed control, including hand pulling, hoeing, and the use of herbicides. It is important to choose the appropriate method based on the type of weed and the severity of the infestation.
When we talk about the controlling of weeds, there can be a lot of factors that are outside of our control. A lot has to do with things like sprinkler systems. Unless your company is working on sprinkler systems and setting them, the homeowner themselves are usually in control. This can be a major problem. Obviously, in dry seasons, it's good if the sprinkler systems are putting out water. But think about this. What if you're in a rainy season in an area like I am in Florida? All that water's going out from the sprinkler systems and it's raining every day? This can be a major problem. Also, weather can be a big factor. As we know, depending on what part of the country you're in, every year the weather is going to be quite different. There's a lot of other factors you have to think about when it comes to weed control, and one of the things I would highly suggest is you having good customer cooperation. If you're not working hand in hand with the customer, you're going to have a hard time controlling weeds on a property.
To conduct an effective weed management program, the manager should be able to identify target weeds to genus and preferably to species, for example, Poa annua, Poa is the genus name. To conduct an effective weed management program, the manager should be able to identify target weeds to genus and preferably to species. For example, Poa annua, Poa is the genus name, and annua is the species name for the annual bluegrass. Accurate weed identification is essential to selecting the appropriate control technique. Grasses are monocotyledonous plants, which mean they have only one seed leaf, cotyledon, present when a grass seedling emerges from the soil. Grasses have joints, nodes, and hollow rounded stems. The true leaves, as opposed to seed or cotyledon leaves, have parallel veins and are several times longer than they are wide. Bermuda grass, crabgrass, goosegrass, and annual bluegrass are typical grass weeds found in ornamentals. I just want to take a moment to mention the fact that when we're dealing with weeds, it's just like any type of pest. Obviously, weeds are a problem, but if we don't identify them correctly, it's going to be very hard to solve that weed control problem. So just keep in mind, as you're sharpening up your skills on identification of weeds, you're really helping yourself start to solve problems and get through situations that would be ongoing and lingering and could really cause you problems with your clients and your service protocols because you won't be doing the right thing if you don't get the identification right. This really goes back to the principles of integrated pest management, IPM, which I'm sure most of you have heard of, so just make sure you're really good at weed identification. Broadleaf weeds are dicotyledonous, which means they have two cotyledons at emergence and have net-like veins in their true leaves. Broadleaves often have colorful flowers compared to the inconspicuous flowers found on grasses. Chickweed, henbit, lespedeza, clover, dandelion, and dock are typical broadleaf weeds. Sedges have solid, triangular stems in most species, which bear leaves extending in three directions, three-ranked. Sedges have ligules and auricles, and the leaf sheath is continuous around the stem. Yellow and purple nutsedge, annual sedge, green, Kalinga, rice flat sedge, and globe sedge are examples. Weed life cycles. The previously listed weed classifications may be further divided into annuals, biennials, and perennials. Annuals germinate from seed, grow, mature, and die in less than 12 months. Annuals may be further classified as winter and summer annuals. Winter annuals germinate in the fall, grow during cool periods, mature in the spring, and then die in the summer. Summer annuals germinate in the spring, grow actively during the summer, and die in the fall. Crabgrass and goosegrass are examples of summer annual grasses. Prostate knotweed is an example of a summer annual broadleaf, while henbit and chickweed are representative of winter annual broadleaves. Biennials reproduce from seed and complete their life cycle in 2 years. Biennials form rosettes and store foods in their fleshy roots the first year, and then flower the second year. Many thistle species are biennials. Perennial weeds live more than 2 years. Perennials may reproduce from seed or from vegetative structures such as roots, rhizomes, stolons, tubers, or bulbs. The ability to reproduce vegetatively makes perennials more difficult to control. Some perennials, such as dandelion, dock, and wild garlic, are actively growing during cool weather, while others, like Dallas grass and nutsedge, grow rapidly during the summer months. Perennials are further subdivided as simple perennials and creeping perennials. Simple perennials, such as dock and dandelion, overwinter by means of a vegetative structure, such as a perennial root with a crown, but they reproduce almost entirely by seed. Creeping perennials can both overwinter and produce new, independent plants from vegetative reproductive structures. Vegetative reproductive structures include creeping roots, stolons, Bermuda grass, rhizomes, Johnson grass, tubers, nutsedge, and bulbs, wild garlic. Most perennials can also reproduce from seed. Herbicides. A selective herbicide controls or suppresses some plant species without seriously affecting the growth of another plant species. Selectivity may be due to differential, absorption, translocation, morphological, and/or physiological differences between ornamentals and weeds. Most ornamental herbicides are selective. Fusilade 2 is an example of a selective herbicide that controls many grass weeds without causing significant injury to broadleaf plants. Non-selective herbicides control or suppress plants regardless of species. Glyphosate, Roundup Pro, glufosinate, Finale, and Diquat Reward are examples of non-selective herbicides. These products are often used for trimming along sidewalks and fences and as pre-plant treatments when renovating or establishing ornamentals. It is important to note that the selectivity of some herbicides is based on rate. Increasing the rate of a selective herbicide such as Princep, Simazine, will move it into the non-selective category. Mode of action refers to the sequence of events, which includes herbicide absorption, translocation to the site of action, inhibition of a specific biochemical reaction, the degradation or breakdown of the herbicide in the plant, and the effect of the herbicide on plant growth and structure. Herbicide movement in plants. Systemic, sometimes referred to as translocated, herbicides are extensively translocated in the vascular system of the plant. The vascular system consists of the xylem and phloem. The xylem transports water and various nutrients in solution upward from the roots where they enter the plant, through the stems, and into the leaves, flowers, and fruits. The phloem conducts food materials from their principal sites of synthesis in leaves to other locations, such as fruits, and developing roots and shoots for storage and use. Systemic herbicides are slower acting than contact herbicides because they require from several days to a few weeks to move throughout the vascular system of a treated plant. Systemic herbicides may be selective or non-selective. Herbicide movement in plants. Glyphosate Roundup Pro is an example of a non-selective systemic herbicide, while Vantage Cethoxidum is an example of a selective systemic herbicide. Most of the systemic herbicides move in the xylem and phloem, with the exception of the triazines, atrazines, simazine, Cencor, which are only xylem mobile only. Contact herbicides affect only the green plant tissue that comes into contact with herbicide spray. Thus, thorough coverage of the weed foliage is needed to achieve optimum control. These herbicides are either not translocated or only moved to a limited extent within the vascular system of plants. For this reason, underground vegetative reproductive structures such as roots, rhizomes, and tubers are not affected. Multiple applications of contact herbicides are needed for long-term control because plants regrow from these unaffected plant parts. Contact herbicides are fast-acting. Symptoms are often visible within a few hours of application. Bosagron, TO, Bentazon is a selective contact herbicide. Reward Diquat is a non-selective contact herbicide. When we talk about things like non-selective herbicides, I think they're especially useful for killing weeds like along fence rows, cracks in sidewalks, areas like driveways. They're non-selective. They're going to kill everything in sight. Whereas if you're treating a nice plush lawn, you would use a more selective herbicide and use it in a smaller area. So it just really depends on what you're trying to do. Obviously, anything coming up through the crack in a sidewalk needs to be killed, and a non-selective herbicide would work very well in this area. Herbicide families. Herbicides with similar chemistry are grouped into families. In general, herbicides in the same family exhibit similar absorption, translocation, and mode of action. It is convenient to combine herbicide families that have similar sites of action into groups. For ornamental weed managers, the importance of knowing which herbicides have similar sites of action lies in developing weed control strategies that minimize the potential for developing herbicide-resistant weed populations. Pre-emergence herbicides are the foundation of an ornamental weed management program. Pre-emergence herbicides are applied to the site before weed seed germination. After being activated by rainfall or irrigation, these herbicides form an herbicide barrier at or just below the soil surface. When the roots or shoots of germinating seeds come in contact with the herbicide barrier, their growth is inhibited. Most pre-emergent herbicides are cell division inhibitors, affecting the emerging root and shoot, which are sites of rapid cell division. Weeds that have already emerged visible are not consistently controlled because their growing point has escaped contact with the herbicide. The primary target of the pre-emergence herbicides is annual grass, but some small-seeded annual broadleaves will be controlled. A variety of factors affect the performance of pre-emergence herbicides. These include timing of application in relation to weed seed germination, soil type, environmental conditions, primarily temperature and rainfall, target weed species, and biotype and cultural practices that follow application. Soil organic matter and clay content have the greatest influence on the activity of pre-emergence herbicide. Ideally, pre-emergence herbicide should be applied just before weed seed germination begins. Applying too early may result in reduced control or no control due to leaching and/or normal herbicide degradation. Pre-emergence herbicides must be in place and activated before the onset of weed seed germination. Activation of pre-emergence herbicides requires 0.25 to 0.5 inch of rainfall or overhead irrigation. For optimum performance, rainfall or irrigation should occur within 24 hours of application. Water moves the herbicides into the upper layer of the soil. Failure to incorporate herbicides will result in a loss through a process such as breakdown by sunlight and escape into the atmosphere as a gas. A quick note on this slide: when we're talking about the activation of pre-emergence herbicides requiring 1/4 to 1/2 inch of rainfall or irrigation, that's something that's better controlled by irrigation in my opinion. You really have no idea what the forecast is really going to do when people talk about rainfall. Obviously, meteorologists are making some educated guesses, but it's going to be really hard for you to expect that rainfall to be right. So I really like the idea of using irrigation where we have a little bit more control on how much water goes on our pre-emergence herbicides. The critical period between application and activation by rainfall or irrigation varies with the herbicide, rate, and environmental conditions. However, it is safe to assume that sooner is better, and if irrigation is available, water in pre-emergence herbicides immediately after application. In warm weather, herbicides begin to degrade soon after application, eventually reaching a level at which weed emergence and growth can occur. Pre-emergence herbicides will degrade to the point of ineffectiveness from 1 to 4 months after application. For this reason, repeat or sequential applications are needed for full season control. A typical cycle of pre-emergence herbicide applications would include an initial application in late winter to early spring to control summer annuals, followed by second application in late summer to early fall to control winter annuals. In some parts of the country, such as the humid South, an application in late May or June may be needed because the spring application will have dissipated by that time. The application timing in your state may vary. When we talk about the timing on putting out our pre-emergent herbicides, basically the optimum time to apply would be when the soil temperature reaches 55 degrees for 5 consecutive days in the top inch of the soil. This can be hard to meet, obviously. You're busy, there's a lot of factors, and you got a lot of clients, so how are you going to meet that? But ideally, that gives you a time range when you're looking at the weather forecast. Think about those top layers of the soil, and when that first inch gets to 55 degrees range for about 5 days, you know it's time to put out your pre-emergence. Post-emergence herbicides are intended for use on weeds that have emerged and are visible. Post-emergence herbicides are applied directly to emerged weeds. In contrast to pre-emergence herbicides, most post-emergence herbicides have little or no soil activity. It is possible to conduct a total post-emergence weed control program in ornamentals, provided multiple applications are used throughout the year. Disadvantages of total post-emergence weed control include the need for frequent applications and the possibility of temporary ornamental injury. Most weed control professionals use a combination of pre-emergence and post-emergence herbicides. Pre-emergence herbicides form the basis of most programs, with post-emergence herbicides used to control weeds that escape the pre-emergence treatments. Established perennial weeds, both grasses and broadleaves, must be controlled with post-emergence herbicides. General guidelines for best results with post-emergence applications are small weeds, adequate soil moisture, and air temperatures between 60 and 90 degrees Fahrenheit. Weeds that are small, 2 to 4 leaf stages, and actively growing are much easier to control with post-emergence herbicides. Control is improved at this stage because young weeds readily absorb and translocate herbicides. Weeds that are stressed due to dry weather, heat, or other environmental factors are more difficult to control with post-emergence herbicides. Applying post-emergence herbicides at temperatures above 90 degrees Fahrenheit increases the risk of ornamental injury. The resistance of post-emergence herbicides to wash off by rainfall or irrigation varies among products. Typically, a rain-free period of 6 to 24 hours is sufficient to avoid a reduction in effectiveness. Even if rain falls soon after the application, some degree of control will be achieved. Rather than a single rate, a range of post-emergence herbicide rates for a product usually is given. Repeat applications at moderate rates are generally more effective than a single application of the higher rate. The follow-up application is timed to be 7 to 14 days after the first or when regrowth appears. Directed spot spraying with a handheld pump sprayer or lever-operated backpack sprayer is one of the most commonly used methods of applying herbicides in and around landscape plantings. Lack of herbicide selectivity and the obstructions created by landscape plants often indicate the use of this approach. Spot spraying solutions are typically prepared by adding a certain amount of liquid herbicide per gallon of spray mix. These are usually given on a percent of total volume basis. For example, to make a 2% mixture of Roundup and water, add 2.66 ounces of Roundup per gallon of water. This method is best for herbicides with little or no soil activity. Soil-active herbicides should be carefully applied on a per-unit basis, per 1,000 square feet, or per acre. When spraying, do not over-apply. The coverage should be similar to that resulting from a light rain. Just wet the foliage of the target weed and move on. Do not spray until runoff. Remember that herbicides can injure non-target or desirable plants. When using any herbicide, research the characteristics of the product and manage the application carefully. Take steps to ensure that herbicides are directed at the target. Use them at a proper rate, at the right time, and on a site that the label permits. Control each application so there is no off-target movement. Herbicide movement may result from drift of spray droplets, volatilization, movement as a gas, contaminated surface runoff water, or by tracking with feeder equipment. Environmental factors affecting pesticide effectiveness. Many factors determine the effectiveness of a pesticide program. Using the right pesticide and applying it correctly are the most important factors that determine the final outcome. However, there are some environmental factors that can have a negative or positive effect on pesticides. Environmental factors that affect pesticides can be divided into three groups: climatic, plant, and soil factors. Climatic factors. Temperature affects the amount of time required for a pesticide to do its job. For example, when air temperatures are between 65 and 85 degrees Fahrenheit, a plant is rapidly growing and herbicides will be more effective. Long periods of cold or hot temperatures will slow down herbicide activity. High humidity allows foliar applied pesticides to enter a plant quicker than at low humidity. During a period of high humidity and moderate temperature is the optimum time to spray a pesticide that must be taken up by plant foliage. Precipitation. Soon after a pesticide application may help or hurt the final results. A moderate 1 inch or less rain just after a soil exploit. Pre-emergence herbicide or soil insecticide will move the product down into the soil where it is needed. A rain shortly after an application of a foliar applied herbicide or systemic fungicide will drastically reduce the level of control. Any pesticide that needs to be taken up through the turf foliage should not be applied if there is a good chance of rain within a few hours. The decision not to spray because of the possibility of rain must be made by the applicator. Just to take this a little further, you're in a huge position of responsibility as a pesticide applicator. You really need to look at things like the forecast and understand that when there could be rain, or especially if it's imminent in the area, you have to be very careful with putting out these types of products. The problem for a lot of people is you're in areas where you get rainy seasons and it could rain anytime. So there's no perfect answer here, but I would say just take a little time to think about your applications and understand what the predicted weather is. And if it's going to be imminent rain, then I definitely would not make the application. Wind is definitely the most important climatic factor. Excessive wind does not have a direct effect on pesticide effectiveness. However, indirectly, it is a major problem. Excessive wind greater than 10 miles per hour distorts spray patterns and hinders the application of the pesticide. Using a drift control additive will help, but knowing when not to spray because of excessive winds is more important. Applying pesticides in the early morning or late evening hours may help avoid the more windy parts of the day. Weed IPM for ornamentals. Weed prevention is avoiding the introduction of weeds into an uninfested area. One of the keys to making integrated pest management effective in controlling ornamental weeds is not allowing weeds to become established. Some common sense steps to weed prevention include 1. Using weed-free mulch, 2. Using weed-free plant materials. Container nursery stock and balled and burlap material may contain weeds. While it may not be practical to return the plants, it will be possible to get a jump on controlling these weeds. 3. Keeping border areas weed-free and preventing weeds from producing seeds. 4. Washing equipment between uses. Another option to consider: advantages of landscape fabrics. Pros: 1. Fabrics reduce the need for or replace the use of chemicals for weed control. These products allow for water and gas exchange 3. The rougher surface tends to hold up mulch better than black plastic. 4. They provide long-term weed control if kept covered by mulch. 5. They improve weed control over the mulch alone. Disadvantages of landscape fabrics. Cons. 1. They are more expensive than black plastic. 2. Installation is more difficult. 3. These materials will not control all weeds, especially perennial ones. 4. They may stimulate surface rooting of trees and shrubs. 5. Weed roots and shoots may grow through and become intertwined in the fabric. 6. The roots of ornamentals may grow through and into the fabric. 7. Seems to create a favorable environment for rodent. Weed IPM for ornamentals. Weed prevention is avoiding the introduction of weeds into an uninfested area. One of the keys to making integrated pest management effective in controlling ornamental weeds is not allowing weeds to become established. Some common sense steps to weed prevention include 1. Using weed-free mulch. 2. Using weed-free plant materials. Container nursery stock and balled and burlap material may contain weeds. While it may not be practical to return the plants, it will be possible to get a jump on controlling these weeds. 3. Keeping border areas weed-free and preventing weeds from producing seeds. 4. Washing equipment between uses. Landscape weed control is not herbicides alone. Approach weed control as an integrated process that combines good cultural practices that will produce dense, vigorous landscape plants with intelligent selection and use of herbicides. To conduct an effective weed control program, 1. Provide proper cultural practices. 2. Have the ability to identify specific weeds. 3. Be familiar with the growth and reproductive characteristics of weeds. Scout for weeds and pay attention to perennial species because they have the greatest potential for creating future problems. The best time to identify perennials is during late summer or early fall. Note the location of various weed infestations. This information will allow you to be ready with the correct plan of attack come treatment time. 4. Have knowledge of the control measures available and have the ability to select and use them properly. Too often, weed control measures are a reaction to an immediate problem rather than part of a well-planned and coordinated program. Weed control professionals should spend at least as much time learning the conditions that lead to weed infestation as they do studying control options after weeds have become established. Pesticide laws and regulations. The label is the law. There are many federal and state laws that regulate the use of pesticides. These laws must be followed to the best of your ability to ensure the proper results and protect people and the environment from unnecessary dangers and contamination. The best way to meet most of these regulations is to follow the directions on the pesticide label. The label in itself is a law, and all directions on the label are to be followed. To do differently is to be in violation of the label and the law. Regulatory matters. Reentry into treated areas. Reentry requirements have been established for ornamental pesticide applications, as have been done for many agricultural pesticides. Ornamental pesticide labels do not address reentry, usually by stating, keep children and pets off the treated areas until the sprays have dried. Some labels may provide a safe time for reentry, such as 12 or 24 hours after treatment. Such label statements are to be followed. They also must be considered when selecting a pesticide. Such requirements for pesticides to be used in parks and other high-traffic areas can cause extreme management problems for the applicator. I want to mention that this is not just a regulatory matter. That is important, obviously, but we need to understand that when something says you can't re-enter an area for 12 to 24 hours after treatment, this is protecting you as an applicator, as a company, whatever the case may be, as well as clients or people using public parks or anything. So everybody understands you can't re-enter an area for, say, 12 to 24 hours because it wouldn't be safe. So this is very important for people, their pets, the environment, companies, liability. Everything works together, but we have to make sure we follow these labels because we don't want to put ourselves or anybody else at risk. Endangered Species Act. The Endangered Species Act, ESA, affects all federal programs and agencies. Since the EPA registers pesticides, pesticides are covered under the ESA. The Act applies to all outdoor applications of pesticides. Basically, no person is to take any action that may harm or kill a federally endangered or threatened species. This includes affecting the species' habitat or food source. Ornamental pesticide applicators are responsible for determining whether or not their actions will harm an endangered species in the area to be treated. Pesticides can contaminate water throughout the hydrologic cycle. Water contamination is directly related to the degree of pollution in our environment. Rainwater flushes airborne pollution from the skies. Pollution is then washed over the land before running into rivers and lakes and seeping into underground aquifers. Since irrigation and drinking water come from the surface and groundwater, any chemical used may pollute our water supplies. While some substances that endanger water quality come from agriculture, most result from urban and industrial activity. Some also come from pesticide use on ornamentals. Whether in agricultural operations or in urban environments, the improper application, handling, or disposal of pesticides can lead to water pollution. When selecting pesticides for use in ornamental settings, choose pesticides that will control the pest and have the least ability to run off or leach into the soil. To achieve this balance, the applicator must be knowledgeable of a pesticide's efficacy and water solubility. Unfortunately, it is often difficult to determine if a pesticide has the potential to leach or run off into water sources. Water solubility information is available on the pesticide's label and the Material Safety Data Sheet, MSDS. However, many MSDSs do not provide water solubility or KOC information. For specific product information, check reference sources and the company's technical sheets. Areas that are designed to drain require special consideration when selecting the appropriate pesticide. Determine if the planting has drain tiles or other drainage systems installed and know where these drainage systems empty. It is not good to move contaminated water from a treated area into any water system. Be prepared for accidents. Hoses sometimes break, drain plugs come out, and sprayers can accidentally be overturned. Have the appropriate spill containment equipment in your vehicle. Waste pesticides can contaminate water. Overapplication or misuse of pesticides can allow these materials to enter the surface and or groundwater. For some of the newer pesticides, drift from soil particles treated with pesticide is a potential source of water contamination. Newer pesticides are often active at very low concentrations, and when bound to soil particles, the pesticide may be picked up by the wind and moved over surface water. When deposited in water, the soil particle with the pesticide attached can then move into the surface water. This is generally not a major problem unless large amounts of contaminated soil particles are moved and deposited in the same area, or unless the pesticide is active on other target species. Improperly cleaning pesticide containers and sprayers often leads to pesticide runoff or contamination of the soil at the mixing loading site. Pesticide sprayers should be loaded and cleaned on an impervious pad. This eliminates concern about spills, causing runoff or leaching problems, avoiding potential contamination of wells from constant small spillages at the same site. When filling any sprayer, either an anti-back siphoning device or an air gap should be used. This prevents the back siphoning of the pesticide mix into the water line if water pressure is lost. If using anti-back siphoning devices, periodically inspect the device to ensure it is functioning correctly. Mechanical back siphoning devices have been known to stick in the open position. Triple rinse, triple rinse, triple rinse. Pesticide containers should be pressure or triple rinsed immediately after emptying to rinse all the excess pesticide from the container. The rinse aid is to be rinsed directly into the sprayer so the rinse aid can be sprayed on the labeled site. This provides a clean container that can be recycled. Wildlife safety. The use of pesticides on turf grass must also take into consideration possible impact on wildlife. Many pesticides are toxic to fish and/or wildlife. Therefore, do not spray pesticides in or on water or under situations that can lead to fish and/or wildlife kills. Also, be careful that pesticides are not applied just before a thunderstorm or irrigation schedule. You do not want to wash the pesticide into the water system. Weeds are unwanted plants that can grow in lawns and compete with the grass and desirable for nutrients, sunlight, and water. Identifying and controlling weeds is an important part of lawn care. The importance of weed identification skills is obvious. It is impossible to look for control information until the weed has been identified. The ability to identify weeds is more important from more than a control standpoint. Often, the first question a client is going to ask is, "What is that weed?" So, weed identification is also useful in establishing your credibility as a professional. Plantain, a perennial weed that belongs to the Plantagenaceae family. Plantain has broad, ribbed leaves and tall, slender flower spikes. Plantain can thrive in compacted or poorly drained soil and can be difficult to control once it becomes established. It can grow up to 12 inches tall and has a deep taproot. Broadleaf plantain is a perennial weed with large, oval-shaped leaves and small, inconspicuous flowers. It is a common weed in lawns and gardens, thriving in compacted soil and areas with poor drainage. It typically grows in compacted soil and areas with poor drainage, such as lawns, gardens, and fields. Broadleaf plantain can grow up to 12 inches in height and has a deep taproot system that can extend several feet into the ground. Its leaves are large, oval-shaped, and have prominent veins. The flowers of the plant are small and conspicuous and usually grow on a long stem. The plant produces a dense rosette of leaves close to the ground, making it difficult to remove by hand. The seeds of broadleaf plantain can remain viable for several years, allowing it to spread quickly and easily. Control measures for broadleaf plantain include hand pulling. Small infestations of broadleaf plantain can be removed by hand pulling or using a hoe to dig out the roots. Lawn care. Maintaining a healthy, well-fertilized lawn can help to prevent broadleaf plantain from taking hold in the first place. Proper mowing, watering, and fertilization can help to keep the grass thick and healthy, reducing opportunities for weeds to take hold. Herbicides. Chemical herbicides can be effective in controlling broadleaf plantain, but should be used with caution as they can harm desirable plants and can have negative impacts on the environment. Selective herbicides that target broadleaf plants, such as 2,4-D, or dicamba, are typically effective against broadleaf plantain. Soil aeration. Aerating the soil can help to break up compacted soil and improve drainage, reducing the conditions that allow broadleaf plantain to thrive. Benefits of aerating for broadleaf plantain. 1. Improved air exchange between the soil and atmosphere. 2. Enhanced soil water uptake. 3. Stronger turfgrass roots. 4. Reduced soil compaction. These benefits can help the lawn in resisting weed growth. Mulching. Covering the affected area with a thick layer of mulch can prevent sunlight from reaching the weed and eventually kill it. Control. Broadleaf plantain can be removed manually by digging out the entire root system. It is important to maintain a healthy lawn through proper fertilization, mowing, and watering. Herbicides can also be used to kill plantain, but may require multiple applications. Whether it's mowing, watering, or proper fertilization, these three things must be done properly. You're not going to be successful in controlling weeds if you don't do these three. That's why we're saying herbicides can also be used to kill something like broadleaf plantain, but may require multiple applications. But also, you've got to do the three things we just talked about, because if you don't take care of the lawn properly, it's futile to go out and spray a bunch of pesticides and herbicides. Chickweed is a member of the Caryophyllaceae family and is a low-growing weed known for its delicate appearance, with small white, star-shaped flowers and small oval-shaped leaves with a pointed tip and a smooth stem. Chickweed can thrive in moist, shady areas of the lawn and can quickly spread to form dense patches. It can grow up to 8 inches tall and forms dense mats. Common chickweed is a winter annual weed that grows low to the ground. It thrives in cool, moist conditions and can quickly spread throughout a lawn or garden. We talked earlier in the course about pre-emergent herbicides. Obviously, you need to apply them in the correct time of year for the weed you're trying to control. That's why we mentioned in this case you need to put them out in the fall. If you put them out in the fall, you're going to stop the seeds from germinating in the spring, reducing the number of plants that need to be controlled. But if you didn't put these out at the right time, they would have little or no effect at all. So just keep in mind you always need to know the biology of the weed you're dealing with and what time of year to put down what type of product. Control. Common chickweed can be controlled with post-emergent herbicides, or small infestations of chickweed can be removed by hand pulling or using a hoe to dig out the roots. Herbicides. Chemical herbicides can be effective in controlling common chickweed, but should be used with caution as they can harm desirable plants and can have negative impacts on the environment. Crabgrass is an annual weed that grows low to the ground and spreads out in a star-shaped pattern. It has wide, flat blades and can grow up to 6 inches tall. It has light green, pointed leaves that form a dense, mat-like clump, and it spreads by seeds and tillers that grow from the base of the plant. Crabgrass produces a long, slender seed head that can reach up to a foot tall and easily reseeds itself in the lawn. Crabgrass thrives in bare, thin areas of the lawn and can quickly spread to take over large patches of grass. Preventing the growth of crabgrass requires maintaining a healthy lawn through proper watering, fertilization, and mowing practices. A thick, healthy lawn will help to prevent the establishment of crabgrass by shading the soil and outcompeting the weed for resources. In this slide, again, you're going to see the recurring theme where proper watering, fertilization, and mowing practices are going to help keep a thick, healthy lawn. And this again helps prevent the establishment of crabgrass because it really is shading the soil from the sun, thus helping prevent the growth of crabgrass and other weeds. On our pop-up in the upper left-hand corner, we're again talking about regular mowing and fertilization to promote a healthy, dense lawn can help prevent crabgrass from becoming established. In cases where crabgrass has already established, pre-emergent herbicides can be applied in the spring to prevent seed germination. Post-emergent herbicides can also be used to control crabgrass, but they should be applied when the weed is still young and actively growing. So once again, we're talking about the pre-emergent herbicides and when they need to be put out. In this case, when you're dealing with crabgrass, you need to put them out in the spring. Once again, I keep saying it, but you need to understand the weed you're trying to control. That way, in this case, you put the pre-emergent herbicide out in the spring, and you have a good result in controlling the crabgrass. Dandelion, Taraxacum officinale, are perennial weeds that have bright yellow flowers and deeply notched leaves that form a rosette. Dandelion, a perennial weed with a deep taproot, yellow flowers, and a rosette of deeply lobed leaves. Dandelions can spread quickly, and their deep taproots make them difficult to pull by hand. Dandelions produce seeds that are housed in a fluffy white structure called a pappus. The pappus is actually made up of many individual hairs, each attached to a single seed. When the dandelion flower head is fully mature, the pappus expands and the hairs become detached from the seeds. This allows the seeds to be easily carried by the wind, sometimes for miles away from the parent plant. The seeds of dandelions are highly adaptive and can germinate in a wide variety of conditions. They can grow in both moist and dry soils and are able to tolerate a range of soil pH levels. The seeds can also remain viable in the soil for many years, waiting for the right conditions to germinate. Control. Dandelions can be removed manually by digging out the entire root system. They can also be controlled with post-emergent herbicides. Clover, a perennial weed with leaves made up of 3 leaflets and small white or pink flowers. Clover can fix nitrogen in the soil, which can be beneficial for grass, but can also create unsightly patches in the lawn. To control clover, it is important to maintain a healthy lawn through proper fertilization, mowing, and watering. Herbicides can also be used to kill clover, but should be applied carefully to avoid damaging surrounding grass. White clover roots are relatively shallow, with the main taproot typically only growing to a depth of about 6 to 8 inches, 15 to 20 centimeters. The roots are fibrous and form a dense mat just below the soil surface. This mat of roots helps to improve soil structure and fertility by breaking up compacted soil and adding nitrogen to the soil through a process called nitrogen fixation. White clover, Trifolium repens, produces small, round seeds that are typically 1 to 2 millimeters in diameter. The seeds are light brown in color and have a hard, smooth outer coating. White clover seeds are commonly used in agriculture as a cover crop, forage crop, or as a component of grass seed mixes. When used as a cover crop, white clover can help to improve soil health by fixing nitrogen, reducing erosion, and suppressing weed growth. As a forage crop, white clover produces a high-quality source of protein and energy for grazing animals like cows, sheep, and goats. Creeping Charlie, Glaucoma hederaceae. Creeping Charlie is a perennial weed that has scalloped leaves and small blue-violet flowers. It spreads rapidly by creeping stems that root at the node. Creeping Charlie, also known as a ground ivy, a perennial weed that grows low to the ground and spreads by producing creeping stems or runners. It has round or kidney-shaped leaves with scalloped edges and small funnel-shaped blue or purple flowers. Creeping Charlie can quickly take over a lawn or garden bed, outcompeting desirable plants and reducing overall biodiversity. It is particularly difficult to control because of its persistent root system, which can regenerate from small pieces of the stem left in the soil. Control measures for Creeping Charlie include hand pulling. Small infestations of Creeping Charlie can be removed by hand pulling or using a hoe to dig out the roots. Mulching. Covering the affected area with a thick layer of mulch can prevent sunlight from reaching the weed and eventually kill it. Herbicides. Chemical herbicides can be effective in controlling Creeping Charlie, but should be used with caution as they can harm desirable plants and can have negative impacts on the environment. Spotted spurge is a common weed in lawns and gardens and other areas of disturbed soil. It is particularly well adapted to dry, sunny areas and can tolerate a range of soil types. It can be difficult to control once established, as it has a deep taproot and can regenerate from pieces of stem or root left in the soil. Spotted spurge is a low-growing weed that has small, oval-shaped leaves that are light green with a red or purple spot in the center, hence its name. The leaves are arranged opposite each other along reddish stems that grow close to the ground, and the plant produces small, inconspicuous flowers in the summer. Spotted spurge, also known as prostrate spurge, is a summer annual weed that spreads by seeds and stems that root at the nodes. Preventing the growth of spotted spurge requires maintaining healthy turf and avoiding soil disturbance. Hand weeding and targeted spot treatments with herbicides, such as those containing 2,4-D dicamba or glyphosate, can be effective in controlling spotted spurge. However, repeated applications may be necessary as the weed can regenerate from small pieces of stem or root left in the soil. It is important to follow label instructions carefully when using herbicides to avoid damage to desirable plants.